Ladies and gentlemen, in my Physics 4A class, I hope you do well. I hope you watched my previous videos about chapter 6 and 7, and also chapter 8, which it was kinematic of circular motion. Now we go on second part of circular motion, which it is called dynamic of circular motion. So let me just review for a couple minutes that I go over important topics on previous video. It's about circular motion. So what is circular motion? If object just rotates about a point, if object orbits around a point, that is called circular motion, like motion of moon around the earth, motion of earth around the sun, okay, motion of all planets around the sun, motion of electron about nucleus inside the atom. So these are example of circular motion. So in circular motion, one of the most important topic, it was tangent velocity. Which what is tangent velocity? As I explained it to you, it's velocity on the circle, and we showed by vt, correct? Tangent velocity. It is tangent on the circle. So it's same as speed of object on x-axis. And we learned that we have also angular velocity, which it's velocity at the angle, velocity at center, angular velocity. So angular velocity, so here it's at the center. We showed by omega, correct? And line or distance from center to circle, we showed by radius. And we saw already in previous video that what is relation between Vt and omega equation is this. Vt is equal what? R omega. This is relationship between tangent velocity, between velocity on the circle and velocity at the center. Pay attention here. And also we learned that omega is delta theta, correct, divided by delta t, or in calculus base, omega is d theta over dt. What is theta? It's called angular position. Theta is called angular position. It is like x. Delta theta, it's called what? Angular displacement. So this is like delta x. This is like x. Position, this is angular displacement. Angular position is theta. Angular displacement is delta theta. Position in chapter 2 was x. Displacement in chapter 2, 3, 4 was delta x, correct? And omega is radian per second because the unit of theta is radian. It's not degrees. So Vt equal R omega was relationship between tangent velocity and and angular velocity. Now, today, Let's go on, add a page. You go here. Let me make another circle here. Okay. The topic that we have, it is called centripetal acceleration. Which we showed this one actually by AC, centripetal acceleration. Look guys, when object is rotating on the circle, we 100% we do have tangent velocity. Let's assume this tangent velocity is constant. Let's assume tangent velocity is what? Constant. So this kind of motion is called uniform circular motion. Uniform circular motion. Let's say Vt is constant. Therefore, this is gonna give us what? Tangent acceleration. This is the tangent acceleration. So At is 0. So let's assume, even if tangent velocity is not constant, again, we do have the acceleration that I'm talking about it. So the new acceleration comes in the game on circular motion, which it is called centripetal acceleration. What is that? It is acceleration. It's an acceleration toward center. Toward what? Center. The center of rotation. Please pay attention here. So it's acceleration toward the center of rotation. That means is, if object rotates on the circle, it has 100% tangent velocity. If object rotates on the circle, it has 100% what? Tangent velocity. And in the same time, guys, it makes acceleration toward what? Center. We showed by AC. It makes acceleration toward center. It makes acceleration toward what? Center of rotation. We show this one by AC. AC. Some book, you can see it also, they go with AR. That means is radial acceleration or centripetal acceleration. Both either works. But I like to go with AC. Now it's up to you. I don't proof equation. Proof is in your book. You can go and look at your book in chapter 8. It's very simple. So what is relation between centripetal acceleration and tangent velocity? So who makes this centripetal acceleration? The answer is tangent velocity. The answer is tangent velocity, which it makes angular velocity. So who makes the centripetal acceleration? Answer is tangent velocity. What is relationship between centripetal acceleration and tangent velocity, answer is this. AC is Vt squared divided by what? Radius. That's all. As I said, proof is in your book, so please go look at your book. Proofing is simple. So this is equation that we have, Vt squared divided by R, by radius. So what can we find also? We know that Vt is equal with what? R omega, correct? Now if I substitute here, guys, I can also find this equation that AC is, instead of Vt, I'm going to put R omega. It's power of 2. It's power of 2 here, correct? Instead of R, it's R. So the answer becomes what? R squared omega squared divided by R. Therefore, centripetal acceleration also can be written as R omega square. Why? Because R with R cancel each other, so we are going to have just R omega square. Either of these equation works, this one or this one. What is centripetal acceleration? It's Vt squared over R or R omega square. Okay. Now, what is the unit of centripetal acceleration? What is the unit? It's meters per second square. It's meters per second square. Why? Because speed or velocity is meter square, is meter per second to the power of 2. So it will be meter square divided second square. Then that divided by meters, makes sense? So will be meter square to the power of 2 divided by meter. So the answer will be meter square divided second square divided by meter. So this will be meters per second square. Correct? Now, centripetal acceleration is toward the center. So remember, when object rotates above the center, what I have, when object rotates above the center, that object gets affected, or an acceleration affects on that object, which it's toward the center. That acceleration is called centripetal acceleration. By the name, we can understand that it is centripetal. It's acceleration toward the center. So do not forget this, please, that AC is always toward the center when object rotates above point. Now, let's add new pages here. The next topic will be called centripetal force. What is this? We showed by FC, centripetal force. As I said, some book goes by FR. Let me write it, or FR. Little r or big R doesn't matter, okay? Radial force, radial axis. So R means is radial axis. R means is radial axis. What is the radial means is radius axis, correct? What does that mean? That mean is where radius of circle is located. So we draw a straight line, we call it radial axis. So it's very similar. Just I'm writing here, very similar is to like what? X-axis. Okay? So do not get confused, please. So radial axis or x-axis, same, nothing changes. Now, what is centripetal force? Look, by Newton's second law, as we have sigma F is equal with ma, acceleration is vector, force is also vector. Therefore, we can say, as we see here, force makes acceleration, correct? Or acceleration makes force. You can see by this equation that acceleration makes force. Therefore, we can say that acceleration, which it was centripetal acceleration, will make for sure a force which is called centripetal force. So AC, here you see AC, makes FC. So I'm going to put the vector arrow on it. Okay, therefore, guys, we know that AC is equal with what? V square, but tangent velocity to the power of 2 divided by radius. If you let me, I'm going to go with little r, okay? Little r or big R, doesn't matter. When we go here, r, it's radius. Little r is also radius. Okay, radius of circle. Do not forget that. So r, it's same as little r. It is radius of circle. The object rotates above that. Or particle. Around center. So I'm going to show little r instead of big R for radius. Therefore, guys, here I can say, let me go right by different color, huh? Therefore, FC, so using this one and this one, I can say that FC will be what? M V T square over what? R. This is gonna be force, centripetal force. And here tangent velocity is actually a magnitude because it's to the power of 2. Or what we can write, total force on radial axis is equal with mvt square over r, or we can write it m r omega square. Either works. So put the arrow on the top of force, please, here. So this is the equation of centripetal force. It is a force toward the center. So centripetal force is a force toward center. Center of circle. Therefore, what can I say, guys? If I say this is the circle, all right? So what I have, as object rotates around the center, it has Vt. In the same time, it has what? AC. And this AC makes what? Force toward center. So far makes sense? Which centripetal force is equal with m r omega square or mvt square divided by r. And we know Vt is equal r omega. Right? Now, now, let me give you one example. Look, guys, for example, let's assume this is a cylinder. This is a cylinder. Here we do have step, okay? That this step can go inside the wall and also can comes outside, all right? So we can move it in and out. Let's assume one person, he stays on this step and the cylinder starts to rotate, so what is rotation means is omega, or tangent velocity. So cylinder starts to rotate, at the certain velocity. When the cylinder reaches, what we see, let's say, this step goes inside the wall, okay? But the person, the boys, the girls, they have nothing under their legs. But what is happening? He doesn't fall. She doesn't fall. She just sticks on the wall. And even she or he doesn't slide down. What it shows, there's a lot of video on YouTube. Just if you type centripetal force walking on the wall, or driving or riding motorcycle or automobile or car on the wall, you will see those kind of videos that you can run on the perpendicular wall without falling. But if you stop, if you decrease your speed, your velocity, you will fall for sure. Okay? What does that mean? That means this. Look, guys. When this cylinder starts to rotate, when it reaches to enough omega, pay attention, it must be enough. So it's not possible at any speed. No, it has to be enough velocity. Then the person will not fall. Why? Because of this. Look, because you have rotation, so rotation creates centripetal force, and that centripetal force is what? Toward the center. Okay, so that centripetal force is toward center. So the person must go toward the center. This person must go toward the center. But this doesn't happen. The person actually pushed the wall. Do you know where that force comes from? It comes from Fc using Newton's third law. For any action, let's say this is Fc, is centripetal force. For this is action force. What is reaction force? That also is Fc. It is also centripetal force. But this Fc, we don't call it centripetal force, we call it centrifugal force. Centrifugal or fugal force. Who makes this centripetal force or centrifugal force? Fc. So who makes centrifugal force? Fc. Who makes centrifugal force? Centripetal force. These are like this. Let me see how. There you go. These are like equal but opposite of each other. But we never use in physics the word of centrifugal force. We do, but usually in the books, no. We go always with centripetal force because they are same. They have same equation, only this makes this makes that, correct? For any action, we have reaction equal opposite of each other. So why this boy or girl, they don't fall? Because centripetal force, which it makes reaction into the wall, that force pushes the person, the boy, the girl, or the object on the wall. So it doesn't let person to fall. Okay? So this comes only by rotation. Remember, if your omega becomes less, this person, he will fall 100%. So object must have minimum velocity to prevent from falling down. Remember this. As I said, go to YouTube and just type riding motorcycle or driving car on the wall, then you will see. And also just type amusement park centripetal force, you will see many different examples. All right, so what is the next topic? The next topic